So today we were introduced to quadratic equations, and we started off by talking about their graphs and identifying its key features. So we have some examples for you here. So we're going to find all the things: the vertex, the axis of symmetry, the domain, the range, the y-intercept, x-intercepts, zeros, and the maximum or minimum of the graph. Remember, our vertex is like the elbow of the graph. It's wherever the graph bends. Well, our graph bends down here. And this point is the ordered pair for negative 9. So my vertex is the ordered pair for negative 9. Well, that same point gives me a couple other things. It's also going to give me my axis of symmetry. The axis of symmetry is the line that splits the graph in half, which I've drawn as this pink line right here. And this line is the equation x equals 4. The reason it's x equals 4 is because it crosses the x-axis at 4. My domain is always, every single time, negative infinity is less than x, which is less than infinity. And what that means is that my graph just goes on forever and ever and ever, and it doesn't stop getting wider. So what we see here isn't the end of the graph. This graph actually keeps going. So we could draw some arrows there. And as this graph grows, it's just going to continue to get wider and wider and wider and wider, and it's never going to stop getting wider. We're going to skip range for now. We're going to skip to the y-intercept. The y-intercept is where the graph crosses the y-axis, which would be here at the ordered pair 0, 7. My x-intercepts are where the graph crosses the x-axis, so at these two values. The first one is 1, and that's the ordered pair 1, 0. The second value is 7, so that's the ordered pair 7, 0. My zeros are the same thing as my x-intercepts, so they are both 1 and 7. And now we have two things left, our range and our maximum or minimum. Well, these two kind of have to do with each other, so let's answer the maximum or minimum first. And the maximum, minimum, and the range both have to do with the vertex. They have something to do with the vertex. Well, the maximum or minimum is if the graph is asking, is this point, our vertex, at the top of the graph or the bottom of the graph? Well, it's at the bottom of our graph, so it's a minimum. And this value down here, this absolute lowest value on my graph, I'm going to draw a dashed line there, is at negative 9. So the minimum of the graph is negative 9. That also tells me that my range is y's that are greater than or equal to negative 9. So because it's a minimum, we're saying that the graph is bigger than negative 9. Negative 9 is the smallest value. It's our minimum value. All right, here's our next one. So again, we're going to identify our vertex. And our vertex is going to be the point that's either the top of the graph or the bottom of the graph, which is here. It's where the graph bends. And this is the ordered pair 2, 4. So from my vertex, remember, there's a couple other things that we can identify. We can identify the maximum, minimum, and we can identify the range. So let's go ahead and do those two, get them out of the way. So let's go with the max or min first. Well, the question is this point the highest point, the maximum point on the graph, or the minimum, the lowest point on the graph? It's at the top, so it's our highest, so it's a maximum, and that value, to draw a dashed line there, is at positive 4. So the maximum value of the graph is 4. So my range is going to be y's that are less than or equal to 4, because 4 is the biggest, so we want the inequality to eat the 4. It's the biggest one. So my graph is everything that's less than 4. The next thing I know also from my vertex is I know my axis of symmetry. It's the line that goes through the middle of the graph. And this is going to be the equation x equals, because it crosses the x-axis right here, at 2, so it's going to be x equals 2. My domain is always negative infinity is less than x, which is less than infinity. And then my y-intercept is where the graph crosses the y-axis, which would be here. That's at the point 0, 0. And my x-intercept is where the graph crosses the x-axis. Well, it crosses the x-axis at two places. Crosses it at here at 0 and also at 4. So we're going to go ahead and do those as ordered pairs. So 0, 0, and 4, 0 would be my x-intercepts. That also gives me my zeros because my x-intercepts and my zeros are the same thing. So my zeros would just be 4 and 0. And remember, when I'm listing out my zeros, when I'm listing the zeros, I just list the x values here. This 0 and this 4. That's where they came from. And our last graph, we first of all need to identify my vertex as before. So my vertex is all the way down here at the bottom. So that's going to give me my vertex. It's going to help me find my range. It's going to help me find my maximum or minimum. Well, my vertex is going to be at, this is 5, so 6, negative 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be at the ordered pair 6, negative 8. So let's skip down to max or min. Well, if I'm finding the max or min, I'm looking at the bottom of the graph. This is the lowest point, so it's my minimum value. And then I'm going to draw a dashed line wherever this minimum is so we can figure out that value. And it is at negative 8. My range then is going to be y's that are greater than or equal to negative 8. Now I want to point out something in case you had not noticed this. I want to make sure that you see this. If you look carefully at your vertex, which is at negative 8, your range is negative 8, and your max or minimum is negative 8. So all of these numbers, all of these have negative 8 in them. That's on purpose. It should be like that. So then I have my axis of symmetry. Well, my axis of symmetry is the line that goes through the middle of my graph and splits it in half. And it crosses the x-axis at 6. So the axis of symmetry is x equals 6. And I want you to note that my vertex went through 6 and my axis of symmetry went through 6. Again, that's on purpose. Those two are always going to be the same every time. My domain is always going to be, without fail, negative infinity is less than x, which is less than infinity. And again, that's because my graph, as it grows, is just going to continue to get wider and wider and wider, and it's never going to stop getting wider and wider and wider. My y-intercept is where the graph crosses the y-axis, which is all the way up here, and that's at positive 10. So that ordered pair would be the ordered pair 0, 10. My x-intercept is where the graph crosses the x-axis. Well, it touches it twice. Once at positive 2, so that would be the ordered pair 2, 0. And the other time is at positive 10, which would be the ordered pair 10, 0. And then my zeros of my function would be 2 and 10. Because remember, my x-intercept and my zeros are the same thing. And notice when I write my x-intercept when I write my zeros, I only include the x values. I don't include the y value of 0.